All right, hello guys. So if we're going to go ahead and continue on with our blood chapter, if you remember last time I saw you, we were dropping drops straight down from a 90-degree angle, and those drops, when they would hit the paper, were perfectly spherical. Now that does happen occasionally in crime scenes, but the other aspect of looking at blood spatter and figuring out um, what those drops can actually tell us is actually looking at what angle those drops hit. Okay, so this assignment kind of focuses on, well, the angle of impact. And it's a lot of times when you see like crime scene pictures or crime scene shows and there's blood spatter all over the back of the wall, they can actually use those droplets to show like where the victim was. It can also help to describe the type of weapon that was used on that victim. So whether it would be something like a blunt force trauma, something like a stabbing wound or gunshot wound, those would all be things we could tell from looking at the blood spatter itself. Okay, so this is just the second small detail of blood spatter. There will be more to come as we keep working through this blood spatter chapter. Okay. All right, so if you take a look at this assignment, the first thing you might notice is there's a little bit of math. Okay, there's a little bit of trigonometry that is going to happen today, but it's really not too bad. Like if I can do it, I think you can do it too. Okay. So if you take a look, this kind of explains some of the trigonometry. And so what we see is that we've got a droplet. It's hitting the floor. We're going to assume that our floor is flat. Okay, now there are different mathematical equations that take into account if the floor is not flat. But since we're just introducing this, let's go ahead and assume that the floor is flat. Okay, and we are going to be using trigonometry, as I mentioned. So if you remember back to your trigonometry days, okay, you had opposite, adjacent, hypotenuse, okay, and your math teacher, okay, taught you SOHCAHTOA, okay, so what we're going to be looking for, so obviously we've got our 90-degree angle, okay, we're going to be looking for this angle right here, all right, this angle right here, and with that angle, okay, from here, we know that to figure out that angle, we would take the opposite over hypotenuse. So opposite over hypotenuse. Okay. Now, how this relates to blood. Okay. So if the floor is our hypotenuse, okay, that would make this our adjacent, okay, which would make this the opposite end here. Okay, so we're actually going to be measuring the width and the length to get us these answers. All right, so you can kind of see that's what they're explaining right here. Hopefully I did an okay job at explaining that. I'm not a math teacher, as you know, okay? But what we do, so if you remember, sine is opposite over hypotenuse, that's the SOH. And so a lot of times when we are trying to figure out the sine of an angle, we take the opposite over the hypotenuse. Okay. Now that works, but the thing is, we are going to use measurements to figure out this information. Okay, so this is actually the unknown variable that we're solving for. So with this, we're actually going to use the inverse sine, which on your calculators, it looks a lot like this. Sometimes it's also called the arc sine. And with this arc sine or inverse sine, okay, the opposite over the hypotenuse. So we already talked about how the hypotenuse is going to be similar to the floor of what we find on our crime scene. And so if the blood droplet hits, okay, it's going to hit here and then continue to spread because there's that momentum. So this is actually going to end up being the length of our blood droplet. So our hypotenuse is going to end up being the length. The opposite side, okay, this side right here, okay, when it hits, and if we were to flatten this down, it would actually be the width of our blood droplet, okay, because as it hits, it would flatten out. So really, okay, really, we're just going to basically be looking at how we can solve for the width and the length. Now, because we have this unknown angle, we can actually rewrite this equation, okay? And technically, that isn't totally correct, okay? But we can rewrite this equation like this. I was getting ahead of myself. To solve our angle. Okay, so the sine of an angle equals the width and the length, and to figure this out, we can use the inverse sine times, okay, the width divided by the length. Make sure we close our parentheses, and that gives us that unknown angle that we're trying to figure out. So let's do an example, because I think those will make things even more clear. We'll do two. We'll do one. We'll go through this one right here, and then we'll do one on the back too. All right, if we bring this a little closer. Okay. So we found this blood droplet right here on our crime scene. So the first thing that I would do, one, make sure you're in centimeters. Yes, I know it's already measured for me, but so you can see it as well. Okay, you're going to measure, okay, the width of this blood droplet from at its largest point. Okay, so you don't want to measure it down here, you don't want to measure it up here, you're going to measure at its widest point. And that measurement is about 1.5, okay, centimeters. Okay. Then you're going to measure the length. Now the length, okay, you're going to measure from the very tip of the blood droplet, so not the narrowed off end, but the part where it actually hits the floor first, which will be a lot more rounded and typically wider. Okay, so you're going to measure from the tip of that blood drop to the beginning of the tail. So notice we do not measure all the way out here when we're measuring. Instead, we only measure to the point where it starts to narrow. A lot of times when we see this in real life or in real pictures, there's usually like a pool of blood or a darker spot here because the blood has actually hit the floor and then traveled that direction. Okay, so it hits the floor here and then travels that direction as forces like friction continue across the floor. We notice that tail is what they call that. The tail of the blood droplet gets skinnier and skinnier. Okay, so the tail actually points towards the direction that the blood was traveling. So the victim, okay, would not be over here. The victim, oh, some good art coming your way. All right, the victim would be over here if that victim got shot, stabbed, whatever, okay, and that blood droplet hit the floor, the blood would continue traveling, okay? So it actually points the direction the blood was traveling. So the victim would be on the opposite side of that tail, okay? But when we measure that, we get a distance of 3 centimeters, okay? Now, a lot of times, they'll show you can simplify it and then take the inverse sine of that simplified form of it. A lot of times, though, I just recommend that you use the formula at the bottom. There's really no need, sorry about that, for that extra step, where you just type it in like this, okay? So on your calculator, a couple things. So obviously, please use your calculator, unless you're really good at doing the inverse sine in your head. Okay, so I'm going to use my TI-84. It's like 10 years old, but they haven't changed that much. All right, so what we see, the first thing we have to check, if you're using your own calculator at home, is go into the mode button. So you just hit the mode button and make sure you're in degrees. Okay, so make sure degrees is highlighted there. If you're in pre-calc or calc, sometimes they'll have you put it into radians, and that's not going to get you the answers you want, okay? Because it's going to give you really funny decimals because it's in a different mode, okay? So always make sure you're in degrees. If you do not have a scientific calculator at home, not a big deal. You can use any other scientific calculator website. You can use Desmos, and a lot of you are familiar with. You can also use this one. It's metacalculator.com. I'll probably put a link to this one in Google Classroom. This one's pretty easy to use as well. But always make sure, no matter whether you're using a website calculator or your own calculator, it's always in degree mode. Okay. All right, so a lot of times I just tell you to type it in like this. So you're going to do the inverse sine. So on a lot of your TI calculators, you're going to do the second button and then the sine. Okay. And then you're going to do the width. So we figured out our width was 1.5 centimeters. Okay. And if you had a ruler that was in inches, make sure you convert it to centimeters, okay, before you type it in. So we're going to do our width, which is 1.5, divided by 3 centimeters. Okay, close our parentheses, and that will give us an angle measurement of 30 degrees, which is what you see up here in that example problem. Okay, so really, it's not a whole lot of math. You're measuring width and length and then putting it into an inverse sine. Okay, but we'll go ahead and do the first one together. So the first one looks pretty similar to some of the drops that we did in class when you were dropping from straight above the droplet, so something that would be perpendicular to the floor or to the paper that we were dropping it on. So we're going to kind of expect from our previous lab that this is probably going to be close to 90 degrees, give or take. But we always double check anyway. All right, so the very first step, make sure you measure the width. Okay, so it's a little hard to tell on the stock camera, but I'm getting the width of this first drop to be right around 1.6 centimeters. Okay, so right around 1.6 centimeters. And so in that first column, this is like the 7th time I've recorded this video, so I already wrote it in. Okay, the width is going to be 1.6. Okay, if I go ahead and I measure the length, okay, once again in centimeters, right, I'm getting it to be 1.6 as well, okay, being almost like a perfectly spherical drop, right? Maybe. So you can go ahead and write 1.6 there. Now the next column, you're looking at ratio stuff. So the ratio of this particular one, don't think so hard, it's not that big a deal. The ratio is going to be just the width over the length. Okay, now they're not always going to be the same. They are here because it's a pretty round drop, but they will not always be the same. And then once you type it into your calculator, so just exposure, okay. If you're typing this one in, it would be second sine to get the inverse sine. We're going to do our width, which is 1.6, divided by our length. Now, some of you in your heads will be like, oh, well, 1.6 divided by 1.6 is just 1. It is. You could also do that too. I don't care. All right. Hit the equal button, and you'll get that to be 90 degrees, which from our last lab makes a whole lot of sense. Okay. Bam. All right. Okay. Now, the only ones that I typically have questions on, and of course you can email me as well if you're having some issues, or leave me a comment on Google Classroom. It's kind of nice because these will be in color for you guys. So when you start to notice, when we get to measuring length, okay, we do not measure the spines. So you would measure just from right here to the top. Okay, and you can see where the blood had actually congealed a little bit in this picture. And same with down here, sometimes I have questions as to where that drop actually ends. So here's where it would hit the floor. So there's the top of the drop. That's the impact spot. And then that blood droplet would slide across the floor, and see this little indentation that's right here. Okay. That is going to be where you would stop measuring. Okay, notice it gets very dark, very congealed right here, and it also begins to narrow and get skinnier. Okay, so that's where you would actually end the length of that drop. Okay, now obviously if you measure it and you're like 0.1 centimeters off, it will change your angle a little bit, but I'll be forgiving towards it. Okay. All right. And really, I think we should be okay. And then, yeah, we should be fine. Okay, so this document is going to be on Edulastic. Okay, so you'll see all of this. If you want to print out a hard copy, measure it on your own, and then type in the answers, you can do that. Or if you just want to measure it on your computer screen, it should still be the same ratio, because it's a PDF file, so it won't like do any weird conversion things or anything else like that. And then I will always go back in and recheck to make sure that if you got it wrong, It was because you did something wrong. It wasn't because there was a grading error on the computer. Okay. So you will see this pop up in Edulastic. Obviously, since